right, this is section 5.1, and it is all about solving systems of equations, okay? And here, just a lot of words, I know, but I'll break it down for you guys. You basically have two methods. You have the substitution method and the addition method, okay? Substitution, you're going to solve either one of your equations for one variable in terms of the other. So you'll have like y equals something, and you'll have an x in there on the other side. Then you'll substitute the expression found in step one into the other one, and then you'll solve that one, and then you'll back substitute the value found in step three into the original equations to find the missing variable, and then you'll check the solution. Okay, so that one, you're going to have x equals something, y equals something for one of your equations, and then you'll plug that one into the other one, solve, and then back substitute it. Okay, then you have the addition method. If necessary, rewrite both equations in the form of ax plus by equals c. Okay, that's standard form. If necessary, okay, this step is the key. Multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the y coefficients equals 0. So there you're trying to zero something out. Okay, so say I give you two equations. I give you a system of equations, and I want you to solve for x. Okay, and maybe I'll say use the addition method. Okay, if I tell you which method to use, and you need to use the addition one, okay, you're going to multiply either one or both so if I told you to solve for x, you're going to want to zero out your y's. Okay, because once you zero out your y's, you would have x equals whatever. Okay, and then once you find that value, if I told you to find both values, you would back substitute again. Okay, and then the number of solutions to a system of linear equations. Okay, if the graphs intersect in one point, the system has exactly one ordered pair solution. So those would look like that, and they would only cross right there, and that would be your ordered pair. If they don't intersect, that means they're parallel. Okay, I'm going to do my best to draw a parallel line. It probably will not be exactly parallel. Okay, that means no solution because they don't cross. They don't have anywhere that they intersect. And if the lines coincide, so if it's the same line, it has infinitely many solutions. So I'm going to draw one line thicker than the other, like that. And the next one is right on top of it. I don't even know if you can see that. I'll do it in red. That would have infinitely many solutions. Okay, so let's work these examples. This one says solve for x, substitution. Okay, substitution is when you'll solve one of your equations for either x or y, and then you'll plug back in. Okay, so let's go up here with this one. So x minus y, I'm going to not go up there. I'm going to stay right here. I'm going to move my y over. So I'm going to add y. And we get x equals y plus 3. So now I know what x equals. All right. So I'm going to plug in this for x in this guy. So I'm going to have 3 times y plus 3 plus 2y equals -1. And then I'm just going to solve. Oops. 5y plus 9 equals -1 minus 9. So you get 5y equals -10. Divide by 5, and you get y equals -2. Okay, I didn't ask you for y, I asked you for x. So you can come back in and plug in your y into this. So x equals -2 plus 3. And you get that x equals 1. Okay, I'm going to make this smaller so that I can have room. Okay, that is how you do substitution. Solve one for one variable, plug it in. If you found the other one, plug back into the original, okay? This one says solve for y, right? So look and see that this one's already solved for y. So you plug it in. 3x minus 4 times 1 minus 2x equals 18. Watch your signs right there with that 8x. So I get 11x minus 4 equals 18. So add 4, and you'll get 11x equals 22. Divide by 11 and get x equals 2. Okay, I want y. So now I can go and plug this back in here. Y equals 1 minus 2 times 2. So y equals 1 minus 4. So y equals -3. Okay. I'm just making these a little smaller so that I can have some room. Okay. So that is how you'll do substitution. It'll make more sense that you need to use it because you'll have stuff like this where it's almost solved or it is solved for a variable. That'll tell you, because I don't think I tell you really what to do on your quizzes and your final or your anything like that. I just tell you solve for y, solve for x, solve these linear systems of equations for x or y or both or whatever. Okay. But if you see something like this, it's just going to make sense for you to use substitution. These, not so much. It makes sense for you to do the addition method where we're zeroing a coefficient out, okay? This says solve for x and y, so it doesn't really matter which one we zero out. But I'm going to zero out x. You could zero out y if you wanted to. So if I wanted to do that, I could multiply this one by -3 and get -6x. And if I multiply this one by 2, I would get +6x, okay? So you get -6x plus 21y, so it's -3 times -7, equals -6, and then you get 6x plus 2y equals -20. Nope, not -20. I didn't multiply by 2, -40. Okay? Well, -6x plus 6x is 0. And then we get 23y equals -46. Then we just solve for y. Okay, there's y. I need both. So then I'm going to go back into the original equation, one of them. You can pick either one, and solve for y. Okay, if I plug it in to, we can do this one, 3x. I was going to say plus -2, but it's just -2 equals -20. And then I'm going to add 2. Divide by 3, and I get x equals -6. Okay. So you just zero one out and then solve for one, plug back in to solve for the other one. Okay. This one, I'm only solving for y. I need y equals a number. Okay. So for this one, it makes sense for me to zero out my x's. Okay. It makes sense for me to zero out my x's because I'm solving for y. So I could multiply this by -6, multiply this by 5, because I would get negative 30x plus 30x. So those would zero out, and I would just be left with whatever that is. Okay. So I get negative 30x minus 24y equals negative 42. And I get positive 30x plus 35y is equal to 75. Okay, those zeroed out, and we were left with 11y equals 33. Divide by 11, y equals 3. And you're done. Okay, so sometimes it makes sense for you to strategically zero out something. Like we were solving for y, so it made sense for us to zero out our x's so that we could get y equals some number, right? Over here, if you're solving for both, it really doesn't matter which one that you zero out, okay? Because you're solving for both, so you need to find y and x. So we could have zeroed out our y's first and then plugged back in and found our y value, because we would have been solving for x. Okay, either one is fine. Like I said, I won't tell you which one to do, but it's going to make sense here and here. That kind of tells you to use substitution because it's just more simple. Okay, here it makes more sense for you to use addition. Okay, but that is section 5.1.